Hey guys, alright, so sorry it's taken me so long to get these videos out, but I have a few minutes now, so I'm going to go ahead and do one for you right quick. You have an exam tomorrow. For those of you who know me, I know you. You have an exam tomorrow, and so hopefully this will help you. This is going to be a quick video about electron filling. And gosh, that train is in the background just trolling right now. Okay, so electron configuration. So I've got a periodic table in front of me, as so should you. When you're doing these, obviously you're going to need one. And I'm just going to do one example that I hope can help you figure these out for all examples, because they all run the same way. So what we're going to do is we're going to do manganese, right? Not to be confused with magnesium, we're doing manganese. So manganese is a transition metal, and so it has 25 electrons. So I'm just going to go up here and write, hopefully you can see this, Mn for manganese. That's what we're going to do. And so the way you were taught to do it in class is really nice. It's really quick, and you can do it using just your periodic table without having to write anything down. So I'll show you that way first. So what you would do is, I'm just going to talk through this, you would start to count. So from right here, you would say, this is column 1, you say 1s1, 1s2 from the helium, and back here to column 1, 2s1, 2s2 from the beryllium. Then you'd move to the p's, so you'd go 2p1, 2p2, 2p3, 2p4, 2p5, 2p6 from the neon, and back here to the sodium, and you'd go to 3s, sorry, right here, this is where I'm getting these numbers, by the way. This is 1s, 2s, 3s, 4s, so it'd be 3s1, 3s2, and then you move to the p's. So this is, remember, recall this is a p block over here. So all of this over here is p block. This is s block, and these right here are the d block. So I probably should have gone over that first. Anyways, where were we? 3s1, 3s2, 3p1, 3p2, 3p3, 3p4, 3p5, 3p6, and so on. Back down here now to 4s, because we're in the row 4 now. 4s1, 4s2. Now here's where it gets a little tricky. You have to remember, since in this row contains the d electrons, you have to remember that you have to count these. So even you have to count these d orbitals next. So even though we're in the 4th row, we have to treat these d orbitals starting from 3. So if you just remember that the d orbitals are always one less than the s orbital that precedes it, then you'll be all right. So even though we go 4s1, 4s2, we go 3d1, 3d2, 3d3, 3d4, and 3d5. So we know we have a 3d5 manganese. So we would write this up here as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d5, right? So 3d5, that's how you would write that. Hopefully this makes sense to you guys, how I got this. And remember, these numbers in the exponent spot, they're not exponents, but they are in the exponent spot. Those added up should equal the number of electrons that you have in your system. So if we add this up, 2, 4, 6, 8, plus 12 more is 20, plus 5 more is 25. That was how many electrons manganese has. 25 electrons. So we did it right. So all these should add up. Now you're going to run into a few cases where you have what's called promotion, where the electrons from this s orbital will promote to the d orbital, and that happens when, so let's see, promotion occurs when you have a d9 situation or a d4 situation. So had this number right here been a 4 or a 9, we would have to promote one electron from this 4s orbital to the 3d orbital. Now this also happens if this were a 5s and this were a 4d, or a 6s and a 5d. That kind of stuff does happen as well. So be mindful of that. But on your exam, when you do this and you work this out and you get this answer, be looking for this number right here. If this ends in a 4 or a 9, you need to promote 1 electron, because it's more stable to have the s orbital half filled and the d orbital half filled or completely filled than it is to have it lopsided filled, as I mentioned in recitation. So, alright you guys, I hope this really helps. I know I just kind of did it pretty briefly. If you have any questions, or if this method kind of confuses you and you want me to teach you a different method, how I learned in high school, that looks kind of like this, 3, 4, 5, 6, and so on. You've got S, 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 so on, and then P, 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 and P, so on. It keeps going. Then we have D, 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 F, 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 and then G, G, and all these keep going on really forever, but there's not that many elements. There's not infinitely many elements, right? But the way this works is you have these arrows that go down through like this. If I could draw them straight, that would be nice. And they just keep going. And the way this works is, this method doesn't really tell you much about the trends of the periodic table or anything, but it does help you know when you need to have a 3 coefficient. Like, it helps you know where your coefficients are. So if you would like to learn this method, please let me know in the comments, or for those of you who know who I am, you can email me, and I will go over this method with you. But I think the standards are trying to move away from this method and to do more of the counting style, right, that we just went over. So but at the end of the day, whatever gets you the right answer and whatever you can understand the best is a good way to go about it. The key thing there is understanding. So anyways, good luck with your studying, you guys, and I hope you do very well on your exam, and I hope this new setup I have of my camera works out. So anyways, I'll see you guys later. Leave a like, rate if this helped. Thanks. Bye.